Today we want to look at adding and subtracting fractions. Here we've got three adding and subtracting problems that we're going to work on here. You'll notice something about all three of these. Each problem, the denominators are the same. When adding and subtracting fractions, the only way to make them really work out well is to have the denominators the same. That means that bottom number of the fraction has to be the same. We can't add or subtract if the denominators are not the same. We'll learn how to change that denominator to make them the same so we can do that in a little segment a little later. But right now we're going to focus on adding and subtracting fractions here that have the same denominator. So when we look at this, we see 7/8 minus 3/8. 7 minus 3 is 4. And the denominator will stay the same, 4/8. That makes sense. 4/7 plus 2/7. Again, 4 plus 2 is 6. The denominator always stays the same when we add or subtract fractions, so 6/7. Here we have 3/5 plus 2/5. 3 plus 2 is 5. The denominator stays the same, 5/5. Well, we know that 5/5 equals 1 whole. So adding and subtracting fractions is a lot like adding and subtracting whole numbers. Only this time we make sure we have the same denominators and the denominators stay the same as we add or subtract. As we continue to add and subtract fractions, every once in a while we're going to run into fractions that have different denominators. 1/2 plus 1/4. Or 7/10 minus 2/5. But wait, you just told me that I can only add or subtract fractions if they have the same denominators, and that's true. So in the case of 1/2 plus 1/4, or 7/10 minus 2/5, I'm going to have to change one of the denominators so that these fractions can be added or subtracted. When I look at 1/2, I look and go, I can count by 2 and get to 4. 2, 4. So I'm going to use the idea of equivalent fractions that we've already talked about, fractions that have a different name but the same value. Equivalent fractions have the same name but a different value. And I'm going to make an equivalent fraction of 1/2 that has a denominator of 4. Well, I know if I multiply 2 times 2, I get 4. Well, I like to multiply my fractions by 1. A fraction equal to 1 would be 2 over 2. When I multiply by 1, I change the name of something, but I don't ever change its value. I can multiply 7,312 times 1, I'm still going to get 7,312. So when I multiply 1/2 times 2 over 2, which is equal to 1, I'm going to get a new name, but it has the same value. 1/2 times 2 over 2, 1 times 2 is 2, 2 times 2 is 4, and then I can just bring my 1/4 over. 2/4 plus 1/4 is 3/4. And that's one of the ways that we're going to see how to add and subtract fractions that have different denominators. So I've got 7/10 minus 2/5. I can look at the 5 and I go, well, I can count by 5s and get to 10. So I'm going to come up with an equivalent fraction of 2/5 that has a denominator of 10 so I can work with these. When I count by 5s and I get to 10, again, it just so happens I can multiply that by a fraction equal to 1, 2 over 2. 2/5 times 2/2, 2 times 2 is 4, 5 times 2 is 10. I can bring my 7/10 over, make that look like a 10. 7/10 minus 4/10 is 3/10. Here we want to practice just a couple more to kind of get that idea of finding the equivalent fraction and then subtracting or adding to make it work. Here we have 2/3 minus 5/9, and here we have 1/2 minus 3/10. Well, again, I'm going to look at this and I can go, I know I have to have the same denominators. I can't do 2 minus 5 and 3 minus, that's not how it works. Got to come up with an equivalent fraction. Well, I can count by 3 to get to 9. 3, 6, 9, there I am. So I can multiply 2/3 times a fraction equal to 1, 3 over 3, to get my equivalent fraction. 2 times 3 is 6. 3 times 3 is 9. So 2/3 is equivalent or equal to 6/9. Didn't change the value, just changed its name. I can bring 5/9 over. 6/9 minus 5/9 is 1/9. Let's do 1/2 minus 3/10. Same idea. Don't have equal denominators, so I have to change the denominator of one of these fractions. Well, I know I can count by 2, 2, 4, 6, 8, 10, and I can get to 10 using that. So I'm going to find an equivalent fraction of 1/2 that has a denominator of 10. Well, when I count by 2s, I count by 2s 5 times to get to 10, so I'm going to multiply by a fraction equal to 1, 5 over 5. 1 times 5 is 5. 2 times 5 is 10. And bring my 3/10 over. 5 minus 3 is 2. My tenths stay the same. 2/10 is my fraction. Now, I know this fraction is not a reduced fraction. We're going to get to reducing fractions soon enough. But this is how we're going to work these. We're going to find the equivalent. We're going to make equivalent fractions by multiplying by 1, renaming the fraction, not changing its value, and then subtracting like we normally would. So remember, when adding or subtracting fractions, you're always going to have the same denominator to add or subtract. You may have to change the denominator of one, if not both of your fractions, to add or subtract. And then once we have it, we add or subtract normally. Numerators only, the denominators will stay the same.